Every time my PC get an IP address. Every time my laptop get an IP address. Every time my printer get an IP address. Every time my smartphone get an IP address. Hello everyone. In a network, if you want to use a computer, a laptop, a printer or even a smartphone, you should have an IP address to communicate with the other devices in that network. In this chapter, we are going to discuss about the IP address and its specification. Welcome to the video. Welcome to CCNA 200-301, Implementing and Administering Cisco Solutions, Chapter number 49, IP Address, Subnet Mask and Default Gateway. In this chapter, we are going to talk about the IP address and its specification. We are going to discuss about the different classes of IP address. We are going to talk about the concept of Subnet Mask and Default Gateway. We are going to discuss about the difference between uni-cast, multicast and broadcast. And finally, we are going to talk about the classful and classless IP addressing. So let's talk about the IP address. What is an IP address? And before we talk about the IP address, I would like to discuss the concept of address. So what is an address? To understand the concept of address, let's go to the boy called Jack. Jack is living in the city and his friend, Mr. Tom, is living in a village. It is very far from the city. Now Jack wants to send a gift to Tom for his birthday, but Jack is not able to travel this distance to his village to deliver this gift. So in this situation, Jack went to a courier company and asked them to send this gift to Tom, who is living in the village. So the courier boy took this gift and he traveled all the way to the village and present this gift to Jack. And Jack received the gift and he was very happy. Now in this scenario, how the courier boy can understand this is the recipient Tom and this gift should be delivered to Tom? It is with the help of the address that is written on the gift. When the Jack submit the courier into the courier company, he mentioned the address of the Tom, the address of the recipient. And there it is clearly mentioned where Tom is living. This may contain the village name, this may contain the street name, this may contain the villa or house number, and it may contain his phone number also to contact. So with all this information, the courier boy can easily understand where Tom is living. So as per the address, he can go to that specific location, specific village, specific street, and the specific house. And he need to search for the person named Tom, so he can find the person. So here we can say that each individual person has an address to identify them. In the village where Tom is living, there may be hundreds of Tom. So how the courier boy identify the right Tom? This is by using with the help of the address. In that village, in that street, in that house, there is a possibility of having only one Tom, that is the recipient. Here is the concept of address. So this is happening in our real life. The same scenario is applicable to a computer network also. In a computer network, there may be multiple network devices connected to that network. And how do we identify each network devices? So if you see in the picture, you can see there is a PC, there is a switch, router, server, and lot of other devices can also possible. So in this situation, when the network devices start communicating, how do they identify each other? It is with the help of IP address. So as like in a society, each individual person has their own address to identify them. Each network devices should have one address to identify them also. This address is called IP address. Now we can talk about the IP address. What is an IP address? The IP address stands for Internet Protocol Address. An IP address is a unique numerical address, 4 bytes long, that is assigned to a device connected to a computer network that uses the Internet Protocol for communication. So here you can see the IP address is a unique numerical address. First of all, it is numerical. IP address contain only the numbers and there is no letters. And other specification, it is a unique one. Unique one means none of the other device should have the same IP address. It is very unique. And it is 4 bytes long. Now let's talk about the functions of IP address. What are the functions of IP address? First of all, it is using for location addressing. When you give an IP address to a device, from that IP address we can understand the location of that device, in which network it is belongs to. And second one, it helps to enable the communication. As I said, in a computer network, if the devices need to communicate with other devices, they should have one IP address. If there is no IP address, then the devices cannot connect to the network and they cannot communicate. So with the help of IP address, device can communicate together. And third function, routing information. With the help of IP address, you can define the route of your packet, which routing table it need to take, in which path it need to go. All this kind of information you can decide with the help of IP address. Another function of IP address is network management and security. With the help of IP address, you can manage your network devices, and also you can provide the security to your devices, such as allow this IP address to that destination or block this specific IP address to that destination, etc. So all this network management and security is mainly we can achieve with the help of IP address. Now let's give more details about the IP address. As I said, IP address is a numerical address that is 4 bytes long. So in this picture, you can see the format of an IP address. In the IP address format, you can see 4 parts, that is 1, 2, 3 and 4. And these 4 parts are separated by dot. So each part in this IP address is called octet. This is called octet. So basically an IP address contains 4 octet separated by the dot. Now each of these octet can have a value from 0 to 255. That means the first octet can value from 0 to 255. Second octet also can value from 0 to 255. Third also, and fourth also. So in this situation, how many possible number can use in one octet? When we calculate from 0 to 255, we can understand that 256 possible numbers for each octet. The value can be from 0 to 255 any number, 0, 1, 2, anything. But the total number of possible value we can use, the total number of count is 256. And in an IP address, each octet is 1 byte long. That means the first octet is 1 byte, second one is 1 byte, third one is 1 byte, fourth one is 1 byte. And when we calculate the total length of the IP address, it is total 4 bytes long. That's why we said earlier IP address is a numerical address that is 4 bytes long. So this is the basic format of IP address. Now in the screen you can see multiple address format. Can you please identify which one belongs to an IP address? From the example we said in this chapter, identify the IP address. Which address is matching with an IP address? We have learned that IP address has 4 octet, which is separated by dots, and it is 4 bytes long. So which address is matching with the IP address here? The answer is this one. This is the IP address. So any one of you identify the proper IP address, that means you understood the concept of IP address very well. I hope everyone understands the concept of IP address. But the IP address is always mentioned along with the subnet mask and default gateway. The IP address cannot function well in a network without the subnet mask and default gateway. They all work together for the efficient network communication. So let's discuss what is a subnet mask and then later what is a default gateway. So the subnet mask. What is a subnet mask? A subnet mask is a 32-bit number that is used to separate a network portion and a host portion. Subnet masks work with an IP address. As we said, subnet masks always work with an IP address. So in the screen you can see different IP address displayed. So let's consider the first IP address 10.10.100. This is the IP address. The IP address we usually give to devices in the network. But how do we understand the location or zone of that device? In which network those device belongs to? That's why we are using the subnet mask. With the help of subnet mask, we can understand in which network this device located. Because subnet mask is used to separate the network portion and host portion in an IP address. Now in the first example, the IP address is 10.10.100 and the subnet mask is 255.0.0.0. So in this subnet mask, wherever you can see the 255, that part belongs to the network. And wherever you can see the value of 0, that part belongs to the host. So when you use this subnet mask along with an IP address, you can understand the first part, because this 255 is represent the first part. So this part belongs to the network. And the remaining three parts, which is mentioned here 0, 0, 0, that is pointing to the 10, 100. This part represents the host part. So when you use this IP address along with this subnet mask, the network can understand the network ID start from the 10. The remaining all parts belongs to the host. So it's not mandatory here it should be 10. It can be 11, 12, 13, 14. And it is not mandatory here it should be 1. It can be 2, 3, 4. And here also it can be 100, 200, 250, etc. So with the help of subnet mask, you can understand the network part of that IP address and the host part. Now when we go to the second example, 172.16.1.100 with the subnet mask 255.255.0.0. So in this subnet mask, wherever you can see the 255, that is a part of network, and wherever you can see the 0, that is part of the host. So in this IP address 172.16 is part of the network, and 1.100 it is part of the host. In the similar way, when we go to the example 3, in the subnet mask, the first 3 portion represent the network and the last part represent the host. So when we see an IP address with the subnet mask, we need to understand the first 3 parties belongs to network and the last part, which is representing this 0, is part of host. Here, to understand the concept of subnet mask, we can go to a previous scenario where Jack was sending a gift to Tom. This is resembled to a computer network. When the courier boy reached Tom village, there is 10 Tom. So which Tom is the person that he was looking for? So that's why we need to specify Tom location or zone in that address. Tom may be living at the 4th street. And when the courier boy reached at the 4th street, there are 10 Toms available. So out of these 10 people who asked the name of Tom, how the courier boy will identify which one is the right one? So here again another concept is coming, the house number. The house number may be 2A103. So when the courier boy reached to this specific house number, there he can see only one Tom. And this is the right person we are looking for. So here how the courier boy identified the right Tom with the help of the address, which is mentioned the street name, house name, etc. So this is the same concept of subnet mask. Subnet mask is the concept used to identify the network device location, in which network they belongs to. Let me clarify the subnet mask concept with the help of a network diagram. In the screen you can see 2 networks are connected with the help of a router, and there is a PC1, PC2 available in the network 1, PC3 and PC4 available in the network 2. Here the PC1 IP address is 192.168.1.10 and its subnet mask is 255.255.255.0. The PC2 IP address is 192.168.1.20 and the PC2 subnet mask is 255.255.255.0. Now imagine PC1 sending some traffic to the destination device 192.168.1.20. So here how the PC1 know the exact location of the destination device 192.168.1.20, the PC2? That is with the help of subnet mask. You can see this is the subnet mask of PC1, 255.255.255.0. That means the first 3 octet of the IP address indicate the network. Now if you go to the PC2 subnet mask, that is also 255.255.255.0. That means the first 3 octet of the IP address indicate the network. So here is the network part of PC1 and PC2, are they same? Yes, both are 192.168.1. You can see here. So what does it mean? It means that PC1 and PC2 are in the same network. Only the host part is different. So when the PC1 sends some traffic to 192.168.1.20, it sends an ARP message to the network switch, that is a switch 1, and understand what are the devices available in the same network and what is their IP address. So with the help of ARP protocol, the PC1 can understand in which interface this PC2 is connected. Just imagine the PC2 is connected to 32nd port. So in that situation, the traffic that is intended to PC2, the destination device, will be forwarded to 30-second interface of the switch port and then PC2 receive the same. Now let's consider another scenario. The PC1 sending some traffic to the destination 192.168.2.100. So that is the PC4. And here you can see the subnet mask of the PC4 is this one. 255.255.255.0 and the IP address is 192.168.2.100. So this is using a class C subnet mask. So the first 3 octet indicate the network part and the last one indicate the host part. So when the PC1 send the traffic to the destination IP address, it check the network part of the IP address. Here the network part of the IP address at PC1 is 192.168.1 and the network part of the IP address at PC4 is 192.168.2. Are they same? No. The PC1 has number 1 at 3rd octet and PC2 has number 2 at 3rd octet. That means they are not in the same network. Even the subnet mask are same. From the IP address we can understand the network portion. In PC1 it is 1 and PC2 it is 2. So that means they are different network. In that situation, what PC1 will do? PC1 will try to forward that traffic to the another network, that is the network 2. So how it can forward that traffic? That is with the help of default gateway. So any traffic that is not intended to the same network, it will forward that traffic to the default gateway. And here, what is the default gateway? The default gateway is this interface of the router, because this router using to route the traffic between 2 different networks. So this interface is the default gateway of the network 1. So anything need to go outside the network, that traffic should be forwarded to default gateway. Then the default gateway will check its routing table and find best path to the destination. It may be to another network or it may be to the internet, depends on the destination. So this is the concept of default gateway. It is working as a entry and exit point in a network. So any traffic need to go out of the network, it need to forward to default gateway. Any traffic that need to come inside the network, it need to come through the default gateway. So what is the default gateway? A default gateway is a router or network device on a local network that serves as a primary access point to the other network, most commonly the internet. A default gateway is considered as entry and exit point to the network. So the definition of default gateway is saying default gateway means an entry and exit point to the network. That means if any communication need to go out of the network, it has to forward to the default gateway. Any communication need to come to inside network, it has to come through the default gateway. So default gateway is basically we can consider as a door in our house. If you want to go out of your house, you need to use the main door. If you want to come inside your house, you need to use the same main door. So in this picture you can see the layout of a house. Here you can see the main door is here. So this is the default gateway for this house. You can enter to the house and you can exit to the house using this gateway, this door. And when you reach inside, there is a bedroom available, there is a washroom available, and there is a kitchen available, and there is a living room available. So here if you want to reach to the living room from the kitchen, what would be your default gateway? This door. This door is your default gateway to reach from kitchen to your living room. And from your living room, if you want to come to the main hall, which gateway you can use? So this is the gateway. And from the hall to bedroom, this is the gateway. And from hall to washroom, this is the gateway. So basically the gateway means it's an entry and exit point. This concept is same with the network also. If you want to reach to a network, you need to go through its default gateway. And if you want to come out of a network, you need to go through the default gateway. Most of the time the default gateway is considered as the interface of the router, because router is the one that separate your local network to outside internet. So most of the time router interface is considered as the default gateway. There are 2 kind of IP addressing are available. One is classful IP address and the second one is classless IP address. We will talk about classful IP address first. So what is a classful IP address? In classful IP address, the IP address were divided into 5 classes. They are A, B, C, D and E. Each class is with a predetermined range. For example, the class A is determined from this range to that range. Class B also same, class C also same. So there is a range provided for each classes. And each class has a class specific subnet mask. For example, if you want to use the class A, it has a predetermined subnet mask that has to be used. For class B, there is another subnet mask. For class C, there is another defined subnet mask. So each class of IP address, there is a specific subnet mask determined. Now let's see what are those different classes in IP address. As we said, IP addresses are divided into 5 classes. The first one is class A IP address. In an IP address, if its first octet is from 0 to 127, that is a class A IP address. And the determined subnet mask for this class A IP address is 255.0.0.0. The second class is class B IP address. If the first octet of the IP address starting from 128 to 191, then it is called class B IP address. And the subnet mask defined is 255.255.0.0. Then the third one, class C IP address. If the first octet is started from 192 to 223, then it is called class C IP address. Subnet mask defined is 255.255.255.0. Then the fourth one, class D IP address. In class D IP address, if the first octet is started from 224 to 239, then it is called class D IP address. And class D IP address is mainly using for multicasting purpose. Then the fifth one is class E IP address. If the first octet started from 240 to 255, then they are called class E IP address. And they are mainly using for experimental purpose. So out of this 5 class IP address, only the class A, B and C are using in the network. Class D is mainly using for multicasting purpose and class C mainly using for experimental purpose. So they are not using that much widely in the computer network. So our target is class A, class B and class C. So in these 5 different classes of IP address, class A, class B and class C are mainly using for unicast purpose. On the other hand, class D is using for multicast purpose and class E using for the experimental purpose. So here is the concept unicast and multicast. What is the unicast and what is the multicast? So we will talk about that now. So there are different types of data transfer method available in the network. They are unicast, multicast and broadcast. We will talk about all these 3 concepts. First take the unicast. The unicast means it is a one-to-one communication. So in this picture you can see the PC1 and it is sending the communication to whom? The PC2. So the source is 1, destination is 1. It is a one-to-one communication. That's why it is called unicast. Now let's see the PC1 is sending another message to PC4. That is also unicast. If the PC1 sent another one-to-one message to PC6, that is also unicast. Unicast means one-to-one communication. Now the second concept is multicast. On the other hand, multicast means one-to-many communication. For example, in this picture you can see the PC1 is sending the data to PC3 and PC6. It is sending the same data to PC3 and PC6. Here sender is 1 but the receiver is more than 1, that means 2. It can be 3, it can be 4, doesn't matter. But if one device sending communication to multiple devices at a time, then it is called multicast. Now let's talk about the broadcast. Broadcast means one to all. That means here in this picture you can see the PC1 sending the traffic to all the devices in that network. So this is a one-to-all communication. That is the concept of broadcast messaging. Now let's talk about the classless IP addressing. Classless addressing is also called classless inter-domain routing, that is denoted by CIDR. It is a method for efficiently allocating IP address and routing internet protocol packet. In CIDR, IP addresses are not divided into fixed classes. That means you can use any IP address and there is no class available. CIDR doesn't use a fixed subnet mask. Instead, they allow variable length subnet mask VLSM. So when we talk about the classful IP address, we said the IP addresses are divided into 5 categories, 5 classes, and for each classes there was some predefined subnet mask. But that concept doesn't exist in the classless IP address. In classless IP address, you can use any IP address with any subnet mask. You are free to use. There is no predefined subnet mask. You can take one IP address from class C and you can use the class A subnet mask along with that thing. Or you can use a class A IP address and use a class C subnet mask along with that thing. There is no problem in that thing. So the CIDR, classless IP addressing, is very effective in the computer networks. Let's see how the classless IP address is helping us to effectively use our IP address. Just consider 2 networks, network 1 on left side and network 2 at the right side. Network 1 using 50 computer and network 2 is using 100 computer. Here the network 1 subnet mask is 255, 255, 255, 0. This is a class C subnet mask. So in class C subnet, how many hosts we can get in a network? This is the network section of the class C subnet mask and this is the host section. So in the host section, there is only one octet is available. So that one octet value can be from 0 to 255. That means total 256 IP address we can get in the class C IP address. But out of that 256, that first address will go to the network ID. Then the last IP address will go to the broadcast ID. So there are total 256 IP address available. But out of this 256 IP address, the first IP address will consider as a network ID and that cannot be used. And also the last IP address can be considered as a broadcast ID. That also cannot be used. So when we remove this two IP address from our count, what we get is 256 minus 2 is equal to 254 possible IP address we can have in the class C subnet. So we have 254 devices we can accumulate in this network, but we have only 50 devices are available. So when we use only 50 IP address, but we use a class C, then here we are going to lose more than 200 IP address. We are not utilizing 200 IP address. It will be wasted. The same situation in the network 2 also. It is also class C IP address. So total they have 256 IP address and minus 2. One is the network ID and second one is the broadcast ID. They also have 254 possible IP address, but they use only 100 computer. So if you reduce 254 minus 100, then 154 IP address they are going to waste. So from the first example we lose how much? We have 254. So from our first example we have 254 minus 50, that is equal to 204. And in the second example we have 154. So this much IP address are going to be not used and wasted in the class full IP address. So that's why the concept of classless IP address is came into the picture. In the classless IP address, there is no concept of classes. You can use any IP address, and there is no concept of a predefined subnet mask. You can use any subnet mask. So if you have 50 computer only, then you can use a network with that 50 computer only. That means the predetermined subnet mask you can convert into a variable length subnet mask, and you can use any subnet mask as per your requirement. So in this situation, the network 1 and the network 2 can just use a variable length subnet mask and they can occupy all of their devices very effectively. So this is the benefit of classless IP addressing. So in this chapter, we talk about the IP address. We talk about the different classes of IP address. We talk about the concept of subnet mask and default gateway. Then we talk about the concept of uni-cast, multicast and broadcast. And finally, we talk about the classful and classless IP addressing. Thank you very much for watching and subscribe to the channel for more videos. Enhance your skills using Irash Academy.